I'm going to be using the game Tic Tac Toe. In the notes, it starts on page 28. It's called Creating Games. You can find that on Canvas. And when you download the project, it's broken into different parts. You'll see I have the Tic Tac Toe graphics.cpp. That's the main program. That's where the actual main is. It has a logic.h file. That is where I could take this and I can copy it over to Cinnamon or Cayenne and take it and create a front end that is console based and use that same thing and create a tic-tac-toe. And there's the logic CPP. When you have a program that has logic that has nothing to do with graphics, you do want to segment it out. This way you can pinpoint if there's a logic mistake versus a graphic mistake. It's very important to separate these into two different areas. I actually created the logic portion first because I had given this project years ago in my 220 class. I have in my logic.h, I have a setup function. I have a 3x3 array of chars. The setup could have been a constructor. I have the set x, the set o, and the done. If I go into the logic.cpp, notice how I do pound include the logic.h at the top of it. My logic function sets the entire board to n. What that is doing is just saying that n means that there's not an x or an o. N represents that nobody has filled out the tic-tac-toe board yet at all. If I am using the set x function, the user has picked an xy location into the array. I'm making sure that that XY location doesn't have an X or an O there yet. I am putting the X in there and then I'm returning true if it's done. I return false if there is already an X or an O there. The set O is a similar function. I first check the XY location that the user has selected. If nothing is there, I set the O and I return true. If something already exists there, I return false and the user can't select that location. The done function is just saying, hey, did we win, did we lose, or did we tie? So these large if statements is honestly checking, did we have 3 across, did we have 3 down, or do we have any diagonals? So it's trying to see, the first if statement is trying to see if X won. The second if statement is trying to see if the O won. This last for loop with if statement is seeing if the board is full and nobody won, meaning that we have a tie between the two. And as I said, the logic H with the combination of the logic.cpp is being used in this graphics game, but it can be used in a console game, and it has, because I've done this on Cinnamon and Cayenne in CPSC 220. In this game here, I notice that, pick a square. All I'm doing is back and forth. And then it says X won the game, screen will close shortly. Again. The O won the game. It's going to close shortly again. And now I have a tie. So in the main file, this is where I am implementing the graphics. The first thing that you'll notice on the graphics end is that I have all of my Allegro functions that I need for here. I have my standard Allegro, I have my fonts, I have my primitives, I have the native dialogue, so this is where I can see out any statements I want to see out to the back. And then the important part is that I have to pound include my logic. In order to communicate with the logic, I have to create an instance of the logic in my graphics window. So in the main, you can see the first thing I do is create a variable called game_logic, and that creates the logic. So I have a graphical representation that I'm going to be doing in this, but in the back of it, I have that two-dimensional array of characters behind it, and that's going to hold the logic behind there. I have a bool game over that is only inside of here, and this is going to be used for the game loop. We started talking about game loops in some of the earlier videos, and yes, I have a game loop here. My game loop is two different things. My game loop says here that while the game's not over, meaning that nobody has won, there's no X winning, no O winning or tie, or done. And that done is the X out window, the display, somebody closes out the window. So somebody can actually X out the window. So my game loop here says as long as we don't have a window or somebody doesn't X out, I want to keep going. I do also have things that I need for graphics. I have the pause X and pause Y. That's similar to what we just did with the mouse. I need to be able to know on the screen where I clicked my mouse button. If I'm in one of the 9 locations where I want to draw an X or an O, I have to be able to know that. If I click in the bottom portion of the screen where I'm putting messages out, I don't want to draw an X or an O. That's where messages are coming out. In order for me to start the game, I want to set up my logic. So notice outside the game loop, I'm saying game_logic.setup. So I'm setting up my Tic Tac Toe game so I can play Tic Tac Toe. Now, while the game sets up the logic, I need to set up my graphics. So here, I am drawing the board. I am flipping the display before I get into the event loop, so this way the board is drawn before I even get into the game loop. This way I have a nice clear screen in order to go. The game over indicates that nobody has won. When I'm inside the game loop, remember this is waiting for an event to occur. The 2 events that I could be waiting for is either the mouse or it could be that I've X'd out the window. If I am waiting for a mouse event, I want to capture the XY position. Now here with the XY position, I want to validate that XY position, but I'm not going to do the validation in here. I'm going to wait till later on to validate that position. If I do click, I'm going to set draw to true because that's going to say, hey, go check some stuff. I'm always going to draw the board inside my game loop, and I'm always going to have a game message. Inside my draw, if the click happens, I'm going to call my set graphics XO position. Let's go to that function. So in my set graphics XO position, this is the corresponding if statement to figure out where on the screen I've clicked. You have to know where each and every box is. In the array, the logic, we can say if we go to 0, 0 or 0, 1 or 1, 1, 1, 2, and set it to X or O. But on the screen, it's not treated the same way. The only way we know if we're in the upper right-hand corner is if we know where the X line is and where the Y line is. So we know that upper right-hand corners, because I designed the screen, is that the X is positioned at 213 and the Y is at 123. So if the user clicks in this area of the screen, then depending on whose turn it is, I want you to draw either an X or an O, or at least I want you to go and attempt to draw an X or an O. If you click between 213 and 426, but still below Y 125, I want you to figure out whose turn it was, see if it's a valid position, and then draw an X or an O. Notice how I am passing 0, 1, 2. So 0, 0, 0, 1, 0, 2. Here I'm passing 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. The fifth and the sixth parameter correspond to the array location of the logic. I'll say that again. The fifth and the sixth parameter correspond to the game logic array positions. So I am saying that this position on the screen corresponds to the board array 0, 0. This position on the screen corresponds to the array position 0, 1. This position on the screen corresponds to the array position 0, 2. So forth. Screen, array. Screen, array. Screen, array, screen, array, screen, array, screen, array. When it gets to turn XO, and what it's doing, it's saying here is, well, whose turn is it? Was 0's turn or is it 1's turn? I do have to take one step back. The function below it, I created a static variable called turn. A static variable is a variable that only exists in the function that is created, but it maintains its value throughout the entire program. So while I initialize it to 0 in the very beginning, when it goes into this turn XO, turn is changed to either 1 or 0. The first time it comes in here, 0's turn means it's going to set an X if that location, meaning if it goes to the logic and that location is available, it is going to draw that X inside of there. Then it's going to swap and say, now it is O's turn. Next time it comes in there, if it is available, it's going to go in there and it's going to draw the O and turn it back to X's position. This function here physically calls draws X and O. How do we know when game is over? When it calls the game message, calls the game logic function done, has 3 variables passed by reference, they're booleans, and it figures out which of these happen. So the important part to know about here is that I've separated the logic out because the logic can work with any front end.